Alright, so what's your thing? What, how do you finish? Well, I never read that. Well, I did, but I forgot it.
Okay, I was going to initiate a 1-minute team talk, but it seems like you guys already took care of that yourselves, so that's okay. I can deal with that. So let's see how we did. Stay on your toes. We got equity bars in effect. So I want the value of x that makes it so that P is the in-center. I want P to be the in-center. And so let's hear from student number 4, 18, 8, and 13. Student number 4, what'd you get?
5.
Student number 18, what'd you get?
5.
Student number 8, what'd you get?
5.
Student number 13, what'd you get? 5. So 4 students in my room got x is equal to 5. That happens to be the correct answer. But now I won't use the equity bars. Where are the brave students who can tell me why? Why is it 5? We'll start with Kamoy. Pythagorean theorem. Okay, the Pythagorean theorem says what?
And a squared plus b squared.
Okay, so we've got a squared plus b squared equals c squared. Very good. So where do you see, and when can you use the Pythagorean theorem? There's specific cases that you can use it with. Kadir? It only works with right triangles. So do we have a right triangle here? So going back to Kamoy. So how many right triangles do you see? I actually see 3 that are obvious, and then there's going to be a 4th one, a 5th one, and a 6th one. So there's actually 6 right triangles that we could use. Which one did you use? Say it again. So you use this triangle right here, P, U, W. Okay? So to use the Pythagorean theorem, we need values for A, B, and C. I see values here and here, but I don't see a value here. How did you take care of that, Kamoy? So why is this x, though? Okay, so the question is, why are they equal? So she is saying that that distance is equal to that distance. Why is that accurate? Why is that an accurate statement? Remember, everything that we do requires evidence and support. Why is that an accurate statement? Okay, so I only have 2 participants for this question. That's fine. Kadir? Okay, so the in-center. Now, first of all, we're trying to find a value that will make this an in-center, but let's pretend for a moment that this is the in-center. If that's the in-center, then it is the same distance from all 3 sides. So in fact, this distance will also be the same as the other 2. And since this one is labeled x, you are more than welcome to transfer that information over to here. So now this is x as well. So now focus back on the highlighted triangle. Now, let's talk about A, B, and C. What does A in the Pythagorean theorem represent? Sharik?
A represents the middle leg.
The shortest leg. So in this case, the shortest leg is which, Sharik?
E.
Yeah, it's going to be represented by x, or at least visually it definitely looks like it. So that means that's x squared. And then what does b represent in the Pythagorean theorem? Sebastian? The longer leg. So the longer leg is 12, so now we've got 12 squared. And what does c represent in the Pythagorean theorem? Nathaniel? The hypotenuse. Thank you for using the big boy word. And so we've got 13 squared. Very good. Solve the equation. So since you last year memorized all your perfect squares, you immediately knew that this was x squared plus 144 equals 169. You subtract, you get x squared equals 25. How do you solve that? Because it doesn't say x equals 25, it says x squared. John?
Find the square root of 25.
Well, that is in essence what happens, but what is it that you're really supposed to do to solve it? Ziamara? Find the square root of both sides. And you may remember that when you do that, when you solve an equation that has a square, you end up with two answers. What are the two answers that we're going to get? Stephen? Very good. We get positive 5 and negative 5. You may remember this symbol we used a lot. So why is the answer positive 5 and not negative 5? Why is the answer positive 5? Go ahead, continue, Stephen. Because distance can't be negative. So we're talking about a distance on an object. It has to be 5. Very good. Any comments, questions about what we've done so far? Anyone do it differently, successfully? Anyone do it this way but come across a mistake and they now know their mistake that they would like to share? Remember, this is a safe place to make mistakes. Even though I push you, making mistakes is expected. Okay, no comments, no questions, no concerns? Okay, well, you've already written the title of the lesson, lesson 5.4. So, we have been working on some complicated ideas, all relating to special segments that can be drawn within triangles. Today we're going to add to that, and things are going to unfortunately get a little more confusing. But we will work hard on keeping our minds straight and keeping things, learning how to distinguish between different ideas. So we're going to introduce the idea of a median and an altitude. So the two special segments you've learned already are perpendicular bisectors and angle bisectors. And then special things happen when we draw all of them. They all are concurrent. They all end up at a specific point. Same thing's going to happen again today. So there's going to be a lot of vocabulary, a lot of ideas floating around. We're going to work hard on distinguishing one from the other. So our objectives are to apply properties of medians and apply properties of altitudes. And some new vocabulary that you're going to see throughout today. So we already know of a midsegment, perpendicular bisector, angle bisector. We already know of a circumcenter and an incenter. Now you're going to learn a median, centroid, altitude, orthocenter. A lot of it sounds the same. It's going to get confusing no matter what. I guarantee it. So it's going to take some time. So let's start with the cheat sheet that I've provided for you. Unfortunately, at the time that I made the cheat sheet, I wasn't as knowledgeable as I am now, and so I've modified it a little bit. So you're going to need to add some things to your cheat sheet. So what is a median? A median is a segment from a vertex to the midpoint of the opposite side. So we're going to use midpoint again. We used midpoint when we did perpendicular bisectors. We're using that again for median. You'll remember that a perpendicular bisector goes like this. It starts at the midpoint, but it's a perpendicular, so it goes straight up. And at many times will actually converge outside of the triangle. But now we're talking about something different. We're talking about a median. a median will most likely, there are cases where it will be perpendicular, but will most likely not be perpendicular, and it connects from the midpoint to the vertex. The three medians are concurrent, which means that they cross at a single point. So if I draw the median from this side to this vertex and this vertex to this side, we would end up with a point. That point is called the centroid. The centroid is the point of concurrency of the medians of a triangle. You saw that the circumcenter sometimes ended up outside the triangle. Incenter was always inside the triangle. The centroid is always inside the triangle. And the centroid is a very useful point because it actually functions as the center of gravity for the triangle, which means that you can actually bounce a triangle perfectly on that one point. Now, so far, most of this is on your cheat sheet. This diagram was not, but you don't have to add that. You could. I mean, it's going to be helpful, but there's some other things that are going to have to be added in, and that is for the centroid theorem. And this was an accident that I missed this major detail at the end, and we're going to be using that idea quite a bit. So the centroid theorem has a different name than what's on your cheat sheet. What's the name on your cheat sheet? Concurrency of medians of a triangle, and it was supposed to say theorem at the end. Well, I've looked through other publishers' books, and every publisher uses slightly different names. That's why the idea is more important than the name. So now in parentheses, you can write centroid theorem. And what it says is, it doesn't matter what the name of it is, but what it says is that the centroid point will take the median and divide it so that one part of it is 2/3 of the whole median. So we're going to look right here at this median. That is a median because you can see that this side is congruent to this side. So this is the midpoint right there, and that's a vertex right there. That's a median, BF. This point right in the middle is called the centroid. What it does is it divides this whole segment into 2/3 and 1/3. You can see that this segment, BP, is longer than BF. And so now we end up with this statement right here. BP will be equal to 2/3 of BF. This right here will be 2/3 of the whole median. And that is true for all three medians. CP will be 2/3 of CD. AP will be 2/3 of AE. We can use this fact to solve problems and to help us, especially considering the centroid also functions as the center of gravity, the balancing point. So, we've got a median, then we take three medians and they converge on a point called the centroid. And then we have the centroid theorem, which states that there's a relationship, 2/3 to 1/3, or 2/3 of the whole median. Any questions about medians and centroids? So if that wasn't mind-boggling enough, let's throw in the idea of an altitude. An altitude is the distance from a vertex to its opposite side. You'll remember that we talked about distance a long time ago, and even more recently I did it again, where I said, well, what's the best way to represent the distance of this table up front to Kadir? Would from here to there represent the distance? Or would the best representation of the distance be from here to Kadir? We talked about that this is perpendicular and that would represent the distance. Distance always refers to the perpendicular distance. So the altitude, think of the word altitude, height, has to be perpendicular. So there's some similarities between this and a median, and there's similarities between this and a perpendicular bisector. So it can get confusing. Not only that, sometimes the altitude will be outside of the triangle. Because, look at this. Let's say that I wanted to try to draw the altitude from Q to PR. So I want to draw this altitude. Well, it has to be perpendicular. That's what an altitude is. Is that perpendicular? Is that? Are any of these lines perpendicular? They're not. So unfortunately, the only way to find the altitude is if we go outside the triangle and have it perpendicular to basically an extension of this side. So the idea of an altitude can get pretty confusing because that some of them are outside of the triangle. Not only that, we are often going to draw 3 altitudes, and it can get very overwhelming. Any comments or questions so far? I'm sure there's many questions, but we're not ready to ask them. So now, the orthocenter. And the orthocenter theorem has a different name on your paper. I think it says the concurrency of altitudes of triangles theorem. The orthocenter, the lines containing the altitudes of a triangle are concurrent, and they form a point called the orthocenter. So you can see this diagram. I find this diagram much more confusing than the other ones that we've seen. I'm still struggling with it personally. So I hope you guys do better than I have been doing. I'm sure you will. But this point G, right here, is the orthocenter. When you find the altitudes, and you draw all 3 of them, they all cross at the orthocenter. Any comments, questions on altitudes, orthocenters, anything at all? So we're going to jump in and start using these ideas. We're going to have some questions that are a little bit easier, some questions that are quite a bit harder. We're going to just look at a range of questions. But one thing I want to be clear about is that what you learn with me needs to be able to be utilized in scenarios that I never presented to you. The point is for you to learn some and then learn how to extrapolate the ideas into other ideas. That's been true all year. It's going to be especially true today. So example 1, part A, using the centroid of a triangle. So, unfortunately, my diagram didn't translate very well when I copied it. So this is not supposed to be some sort of lightning line. It's supposed to be a perfectly straight line. All these blue lines. So, some of your work today is going to be a sketch, and some of it's going to be actual perfect drawing. This can be a sketch. You need the sketch because you need something to refer to. Triangle RST. Q is the centroid. SQ is 8. Find QW and SW. So we are focused here. Because Q is the centroid, something automatically happens to this segment, SW. There's a relationship there. And so we can use what we learned in the centroid theorem, that SQ will be 2/3 of SW. Now remember, when I write SQ like that, that's a variable. If I write it like this, that's an object. Without the bar above it, that's a variable, which means that we can actually replace it with a value. So SQ equals 2/3 of SW. That we got from the theorem. So now plug in what we know to find what we don't know. We were asked to find QW and SW. Well, here's SW. We can find it now. SQ is 8, so plug in 8 equals 2/3 times SW. Solve the equation. That's a one-step equation for you. You can go ahead and solve that yourself. What does SW equal? Give me a thumbs up when you've got it. 1 person, 2, 3, 4, 5, 6, 7, 8, 9. Kalasia, what does it equal? I'm sorry? 12. What did you think, Alexander? SW equals 12. So we've got half of our answer. SW equals 12. Now we need QW. QW can be deduced from the rest. What is QW going to be equal to? Sharif?
4.
4. So QW is going to be 4 because it makes up the other piece of SW. So any questions on using the centroid and the centroid theorem to help you find a piece of information? Any questions, comments, concerns? Okay, so now let's go a bit deeper. Finding the centroid. So now we're going to work a little bit more deeply. It's going to take us a little bit longer. Finding a centroid. The vertices of triangle FGH are given. Find the coordinates of the centroid P. So we're going to work simultaneously for a little while, and then we're going to talk about a couple things, and then we'll work simultaneously again. So you need us to set up a grid. Everyone should have a ruler. I already have my grid set up, and then we're going to plot F, G, and H and draw the triangle. So I'm just going to go ahead and do that, and you're going to do it as well. I'm going to kind of model. I'm just going to talk through it as I do it. You guys know how to do this yourself. 2, 5, 1, 2, 1, 2, 3, 4, 5. There's F. G is 4, 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 6, 1. 6, 1 right there. Now I'm going to connect them and I'm going to label them. Make sure you label because that is going to help us speak to each other and communicate to each other in math terms. So this is F, this is G, and this is H. Okay, so you should have the triangle along with me. Now, finding a centroid. A centroid is based on what type of special segment? What special segment do we use to then create a centroid? If you need to look it up now, that's fine. What's the type of segment we're going to use? Stephanie? Medians. Medians rely on midpoints. So we need the midpoints. So, here's where I want to pause to model a little bit. We need the median of FG. It's not a guessing game. I think this might be the median because it looks like it's about halfway and it's on the grid, but it's not a guessing game. And here's where mental math and your higher math ability makes your life much easier. How do we find the median of any segment? How do we find the median? This is a moment where all hands are frantically waving in the air. Oh, I know, Mr. Gowd, I know, right, Matthew? I know how to find the median. How do we find the median? This is not looking at something. This is from your brain. So I'm sorry I put you on the spot, but this is part of the class. It should be instant recognition. You're going to kick yourself when you hear it, because Kayla's going to say it right now. Right, but I'm saying, how do I find a midpoint? The midpoint formula, of course. And the midpoint formula is a joke. You don't need a formula. You should know that you take the two x coordinates and you average them, and then you take the y coordinates and you average them. So Matthew, again, I apologize for putting you on the spot, but you gotta know the basic stuff so that we can work through this more complicated stuff. So watch what I do. I'm going to find the median of FG. 2 plus 4 is 6, divided by 2 is 3. 5 plus 9 is 14, divided by 2 is 7. So the median is going to be at 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. There's the median right there. Now I did it for FG, you do it for GH and for HF. Do mental math. If you can't do mental math, then write it down. But these numbers will actually work out very nicely, so go ahead and do it. You done already? What's the median of, what's the midpoint of GH? 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. He's saying that's the midpoint. Let's see if he was right. That's 10 divided by 2 is 5. That's 10 divided by 2 is 5. Yep. What about the midpoint of FH? What is that, Nathaniel? 4, 3. Let's see. FH. 2 plus 6 is 8. Divided by 2 is 4. 5 plus 1 is 6. Divided by 2 is 3. 4, 3. There's the midpoint. So remember, we are trying to find a centroid. And a centroid is based on medians. The medians rely on the midpoints. Now we can use our ruler and draw the medians. The median goes from a midpoint to the opposite vertex, or you could say from a vertex to the opposite side at its midpoint. So this median is going to go from H, it's going to go from H to the midpoint. There's a median. This midpoint is going to go from G right there. And this midpoint is going to go from F. This median is going to go from F to the midpoint of the opposite side. And so now we think we've got the centroid. It's where they cross right there. And we were asked to find the coordinates of the centroid P. So now we can say that P is where? You already got it, John? What is it? 4, 5. Let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, 5. And so that is the centroid. there is actually a shortcut for finding the centroid, and I'm going to throw it out there to my super advanced students. There's a simple mathematical way to find the coordinates of the centroid. See if anyone can figure it out. If you can't figure it out today, we're going to be doing an exploration next time. You might figure it out next time. So that is finding a centroid. Does anyone have any questions? We also proved the centroid theorem here. Because look at this segment from G to the midpoint of the opposite side. And look at from P to G. We can count the units. 1, 2, 3, 4. And the whole median is 6. 4 out of 6 is 2/3. You can also see it right here. F to the midpoint of the opposite side is a total of 3, but from F to the centroid is 2 out of the 3. So in both cases, it works out to 2/3. So we have also shown a visual proof of the theorem. Does anyone have any questions on what we did? So we started out using the centroid to find a missing piece of information, or 2 missing pieces. And then we learned how to actually find a centroid itself. Any questions or comments? All right, so let's see what you can do on your own with checkpoint number 1. You do not have to draw anything, but you need to find me the answers to 3 questions. Part A, Part B, and I don't know why that says A again, that should be Part C. So I apologize for that. This is Part C. Three questions, you got 2 minutes. If you finish before the time ends and your teammates are done, you may team talk to see if you arrived at the same answers. All right, give me a thumbs up if you have answers to all 3 questions. Okay, so take another minute. And again, if your team is all done, you can compare answers, but I have a lot of people not done. All right, equity bars in effect. Here we go. For part A only, I got student number 13 and student number 1. Student number 13, what'd you get? 12. Student number 1, what'd you get? Oh, now I'm going to go to you.
Got 13.5.
13.5. So we have a disagreement, which means I go to student number 4. Student number 4, what did you get?
13.5.
The correct answer is 13.5. Part B. I got student number 5 and student number 20. Student number 5, what'd you get? Student number 20, what did you get? Okay, we got a disagreement again. Student number 18. I'm sorry? 12. You also think it's 12? Correct answer is 12. And I got student number 6 and student number 2 for part C. Student number 6 and student number 2. Student number 6, what'd you get?
18.
Correct answer is 18. So, what I've seen with this class and my other class, that part B threw off some students because we didn't really talk about it, but we didn't really need to talk about it. Could someone tell us what is this point right here? What is that called? This is another moment where hands should be frantically waving, right? Kamoy, what is it? It's a midpoint, which means that if BD is 12, what does that say about AD? Can someone use a big fancy word, Alexandra? Okay, so what does it equal?
Oh, it's just wait. So we asked what is 18 equal?
Yeah,
12.
12. Because these two segments are what? These two segments are congruent. Because that's what a midpoint is. A midpoint is the point that divides one segment into two congruent segments. So if that's 12, then that must be 12. So we didn't talk about that, but we didn't need to because you already knew it. Any questions about checkpoint number 1? Any concerns? Okay, so we've spoken about medians and centroids. So now we move to the idea of the orthocenter and an altitude. So I am going to warn you that I am personally struggling with the idea of altitude. I am finding it very challenging myself. So hopefully we'll do okay together as a group. I apologize. I can only do what I understand, and I don't really have anyone helping me right now, so I'm just doing the best I can. So, we're asked to find the orthocenter. The orthocenter is based on the altitudes, which means we're going to need the triangle, and then we need the altitudes, and then we need the point where they cross. Follow the logic? So we need the triangle first. So let's work simultaneously. I'm going to work up here, and I'm going to talk as I do what I'm doing. You guys go ahead and work independently on constructing triangle XYZ with the vertices. And I apologize that y's coordinates jumped to the other line. Y is at 3, 6. Okay? So 3, -2, right there. 3, 6. 1, 2, 3, 4, 5, 6. Right there. 7, 4, 5, 6, 7, 1 is right there. And this is a triangle, so we'll connect the points. Form a triangle. Please be as accurate as possible when drawing a triangle. It will make a difference with the results. I'm sorry, this is x, and that's y, z. So we need the altitudes. And the altitudes are all going to meet at a point, or cross at a point, called the orthocenter. But we haven't really done anything with altitudes yet, so let's work on that for a couple minutes. So here's what I've come up with, and this actually came to my mind between doing this with group E and doing it with you. We need a line that goes from xz to y. But the line has to be perpendicular to xz. So it can't just be any line. So I'm going to do some lines that are wrong. Okay? That is definitely not perpendicular. That's not perpendicular. That looks closer to perpendicular, but I think you can tell that that's not a 90-degree angle. That looks like it could be maybe even there, I don't know, maybe somewhere around here looks like is going to be my line. So the question is, where? Where is the line going to be? There's no guessing. It's not a guessing game, and I'm not asking you to take out your ruler and take a guess. It has to be exact. So there is math involved. So let's talk about the math involved, and watch this. I'm going to take this side out, and I'm going to take this side out, and I'm going to put them back later. We need a line perpendicular to this line that passes through that point. Do you remember ever hearing anything, any question like that before? I want a line perpendicular to xz that passes through y. Have you heard that any time before? Kamoy, what do you think? Okay, so you're coming back, memories are starting to come back. This is actually a concept you learned last year that we actually reviewed this year. So this is not something that we can do simply by finding the midpoint and then drawing a line. We have to use some slightly more complex math. We need the slope of this line, and then we need the perpendicular slope. So what was the word you said, Kamoy? Is that how you find a perpendicular slope? There was a two-word phrase. What's the two-word phrase? Alexandra? Opposite reciprocal. So a line that's perpendicular to this line, the slope will be opposite reciprocal. So we need the slope of xz. Everyone has a triangle on their paper. You go ahead and find me the slope of xz. I'm going to write it down. What is it going to be? What's the slope of xz? Oh, I'm sorry, let me ask you differently. Give me a thumbs up if you have the slope of xz figured out. Good. Matthew, what is it? 3 over 4. So let's see. Rise 3 over 4. So we get 3 over 4. So the slope of our altitude will equal what? The slope of our altitude will have to be what? Kadir? Negative 4 over 3. Opposite reciprocal means flip it and flip it. Flip the number, flip the sign. So the slope of the altitude will be negative 4 over 3. So just watch. I'm going to do something wrong first, okay? So I could start right here, and I could go down 4, 1, 2, 3, 4, over 3, 1, 2, 3, put a point right there, and draw a line through them, right? That is perfectly perpendicular. But the question is that the correct perpendicular? Because look, watch what I can do. That's perpendicular, that's perpendicular, that's perpendicular. In fact, if I extend it all the way over here, all of these will be perpendicular. So the question is, where is the altitude, the one that goes through that point? We have to find that perpendicular line, okay? So, instead of starting here and using that slope, we're going to start right here. Because that's the slope of the line, it has to pass through this point. So watch what we do. Go down 4, 1, 2, 3, 4, over 3, 1, 2, 3, put a point, and draw a line through those. And that will be perpendicular to xz passing through y. So here is the altitude. And you'll notice that it is not exactly where this was. You'll notice that it's not the same line. So that's finding an altitude. But to find the orthocenter, we need another altitude. So let's do this again, except let's use x and yz. So now we need a perpendicular line to yz that passes through x. Move this over here. So again, we're talking about slope. The slope of yz. What is the slope of yz? Go ahead and figure it out and give me a thumbs up when you've got it. Okay, Stephanie, what is it? -5/4. Very good. So what will the slope of this new altitude? What will the slope of this altitude be? John? Yeah, opposite reciprocal. Flip it and flip it. It will be 4 over 5. So now, use that slope, but start at x. Because it has to be perpendicular to yz passing through x. So we're going to go up 4, 1, 2, 3, 4, over 5, 1, 2, 3, 4, 5. And so here is my point, and I just lost it. Let me do it again. 1, 2, 3, 4, 3, 4, 5. And when I draw a line through those, we get the altitude and now let me put back the original triangle. And you can see, first of all, we only to find any of the special points, we only need 2 special segments. You don't need the third one. You can always find what you need with just 2 of the segments. But you can see that they're meeting right about there. Looks like they're meeting right there. So we're going to take a guess that that's the orthocenter. So now we need the coordinates of that. And you can call it, I don't know, point, what do we got? Point W? So let's see. We got 1, 2, 3, 4, 5, 6. Looks to be about 6 3/4. 6.75 or 6 3/4, and it's on the 1, so comma 1. And that is the orthocenter. If I did go ahead and draw the final altitude, is easy because this is a perfectly vertical line, and a perpendicular line to that will be that line right there, and you see it goes right through that same point. So we didn't need that last altitude. We only needed 2 of them. So finding an orthocenter is definitely challenging. It gets very confusing with the picture. So what I would encourage you to do is think about the fact that you need a perpendicular line to a vertex. Get rid of the other lines so that your brain doesn't get too overwhelmed, or use your hands to block them out. Okay? Are there any questions about what we did here? I'm sure there will be. So, checkpoint number 2. Show that the altitude to JK passes through the orthocenter. So I've given you a lot of information, and I've given you the orthocenter. It's right here in green. So first start out by drawing the triangle, because you're going to do some of this visually and some of it mathematically. Start out by drawing triangle JKL. You can see the coordinates. This is going by ones. This is 1, 2. This is -1, -2, -3, -4. That's what the black writing is. This goes all the way up to 7. Okay, so we got about 3 minutes. I don't know if that's enough time, but do what you can in 3 minutes. apologize, that was not really enough time to accomplish what you needed to. So I apologize for that, that's my fault. But I am out of time and I need to wrap up. So let me show you what I was hoping you would figure out. The slope of the perpendicular line. Did anyone figure out the slope of the perpendicular line? Stephen? Yeah. Once you figure out that the slope of the altitude is going to be negative 1/2, you can prove it. Because if you start at L, and you go up 1 to the left 2, up 1 to the left 2, you see that it passes straight through the orthocenter. So that fact alone visually shows it. Here's the part that I was hoping we were going to get to, but we will have to explore at a later date, is that you can write the equation of the line. The equation of the line will be y equals negative 1/2 x plus 3 because it passes right through 3. And then from there, if you plug in the coordinates of the orthocenter, it comes out to a true statement. So I didn't expect you to do that. I didn't expect you to do anything from here down. I expected you to tell me the slope of the altitude was going to be negative 1/2 and visually show that you can go up 1 over 2, up 1 over 2, and you cross right through the orthocenter. Okay? We're going to explore this more tomorrow. So, draw a line across your paper. Your homework is page 324. Make sure you copy this correctly because it is a little bit scattered. Numbers 3 through 10, 13 to 24, 33 to 35, and then 41 and 42 is supposed to be part A only. Part A. Make sure you write A. And you will have a test in chapter 5 after holiday vacation. Also remember